The link in the chat box. So this is a official link for downloading the Anaconda IDE. Okay, so after clicking this tab, so you can navigate to this process. After downloading this Anaconda, you can. This is a basic installation process. We can anyone can install this Anaconda. So this is a basic installation process. Like we are choosing the downloaded file. So after right clicking of that file, so you'll get the installation button. So just click the installation. You can easiest way to install this particular Anaconda. So just click the next button. After the next, we can click the install. So after it's take around 3 or 4 minutes time. After installing this process, put I agree button. So this is an installation process of IDE. Okay. So after you getting the installation, you will navigate to this page. So this is a home page of Anaconda Navigator. Is there any is there any doubts regarding this installation process of Anaconda Navigator? If there is
So
no
can you wait
doubts,
for
we
some
can.
minutes? So can you wait for some
Yeah,
minutes
sure,
and download it?
sure, ma'am, sure,
Sir, please wait for some time, sir.
sure, ma'am, sure. So, dear participants, there is a no mandatory for this software. If you are using mobile phone itself, listen carefully, and we will share the recording link for your reference. You can try after the sessions also. If you have a laptop and a system, you can try now. If there is a no laptop, you can try after completing this workshop.
So if we have tab, like which we have to install, so Linux, in case if you're having tab.
Ma'am, your voice is
If
not
you're
clear,
having
ma'am.
tablets, if you're having tab, which folder we have to
Okay.
install, sir? Whether it is Windows, Mac,
The
or
tab contain the
Linux.
Android or Linux.
Android, sir. Android.
No, ma'am. The Android this Anaconda is not available.
Okay, because it was showing, not showing.
Mm.
Sir, can you go to
So we
first
have
menu?
a yeah, sure, ma'am.
Yeah.
Maybe this way, this layout will be changed. This around taken from uh, before 6 months of this. Now, just wait. I will do the hands-on. Just wait. I will share the real screen
Okay.
of that web page. Okay, so just search. Is the screen is visible?
Yes, sir.
Okay, ma'am. Thank you. Yeah, so this is a real page of Anaconda. So just we'll do the step-by-step process, Anaconda. So just search anaconda.com in the browser. It's navigated to this website. Okay. So after this, we can will get the download option in the bottom of the screen. Yeah, yes. So here we have a install Anaconda button. So just click this. You can navigate it to the page. Okay. So here we have a download button. So just click the download option. Yeah. So after clicking this download button, you can navigate it to the download page. Yeah. So this is a page two downloading. So I have already downloaded. So now now this version take around 899 MB. Suppose you don't if you don't have the data, so after the workshop you can download. Suppose if you download this file, your data may be completed. So we request the participants, if you have that much of data, you can download this file. Suppose if you don't have that much of data, so just listen the workshop carefully and explore the hands-on session on after the programming. So
Sir,
the previous version around its take, yes, ma'am.
sir, on the main page of the website, we have to go down, sir, for Windows, Linux.
Yeah, yeah, yes, ma'am.
Okay, okay.
The ma'am, the website is updated, ma'am. That is a in my slide. That is a previous version of this website. Now
Okay, okay.
they are updated like this. So in this that bottom of this top corner, we have option free download. So just click that. You can navigate it to this. In the home page, the top right corner, we have a free download option. So just click that. You can navigate it to the downloaded page. Here we have an option. So if you are using the Windows, just click the first tab. If you are using Apple or some other versions, you can click. If you are using based on the preference, you can choose.
Okay, okay. Thank you.
Okay, ma'am. Dear participants, we are requested, suppose you don't have that much of data, it file take around 899 MB. If you don't have that much of data, so please listen carefully for this workshop. We will share the recording link also. So after the programming, you can explore this workshop. If you have that much of data, you can download it. Just install that.
So good afternoon, sir. Sir,
Yeah, yes, ma'am.
instead of downloading the Python Anaconda, can we
Okay,
use
ma'am.
it in any way online to work Anaconda online?
Ma'am, we have a possibilities like a code in cloud. This option. So this is also useful to access this. But if you install this software, we can will get the more advantages. If you are using the cloud, we can't access the particular code with appropriate result. If you are download the software, we can access through the software.
Okay, sir.
In the cloud, we have a certain limited options for managing that codings.
Oh, okay. Thank you, sir.
Okay, ma'am. Yeah, participants, shall we start the session? Yeah, yes, we can use some
So,
other IDE as well. So we have a many IDEs for exploring the Python coding. Can access if you are well versed in some other IDEs, you can access that also, sir. But the Anaconda is very user friendly, so that's why I prefer this Anaconda. Suppose we have some other IDs best for us, you can use that also.
completed download, sir.
Ma'am?
Completed a download, sir.
Okay, ma'am. Thank you, ma'am. Okay, so after downloading, I have shared the slide. So the same process, you can install that IDE. So following the slides. In today's topic, we'll cover the basic concepts of Python and as well as basic programming, programming in mathematics. So tomorrow we have advanced mathematical concepts like how to use this Python programming in graph theory and how to use this programming in some other concepts like discrete mathematics, operation research, like that concepts. So today we will see about some basic concepts, how to do the differentiation, integration, and some other calculations. For example, simplify the equations. We have polynomial equations like that. How to see the total number of AP and GP like that. Today's session is the basic concepts. So tomorrow we will explore in the advanced concepts. Shall we start?
Yes, sir.
Sir,
Yeah, sure.
Yes,
I
sir.
hope. Okay. After downloading the Anaconda, so you can see this type of navigator window. So this is a home page of Anaconda Navigator. So in this Anaconda Navigator, we have a many programming languages. Like we have a data spell and we have a Jupyter Lab, we have a Jupyter Notebook, PowerShell, we have a Qt console and a Spider, we have a data lore, and we have a IBM Watson Studio and Oracle. We have a console, Gluvis, Orange 3, PowerShell, PyCharm Professional, and RStudio. Okay, so this is not only for Python programming. From this IDE, you can access the following programming as well. Okay, so we can use our programming through this Anaconda itself. Okay, so here we have a RStudio. So just click the install button. So within fraction of seconds, the RStudio will be installed for your laptop. You can access the RStudio with the Anaconda itself. Okay, so if you want to access some other tools as well. Okay, so for example, if you want to access the Jupyter notebook, so just click the install. Before starting this, here we have an install button. So just click the install button. The within fraction of second, Jupyter notebook will be installed. Okay, so the next step is to install the Jupyter notebook for this workshop. Okay, so if you are in the this page, just click the Jupyter notebook. So I have already installed this Jupyter notebook. That's why I have a launch button. Suppose if you are not installed this Jupyter notebook, if you are not installed this Jupyter notebook, you have a install option instead of launch. So just simply click that install button. So Jupyter notebook will install. After installing this Jupyter notebook, this will be like this. We have a launch button. So if you just click the launch button, so Jupyter notebook will be opened with your browser. Is there any doubts regarding this? Dear participants, do you follow this? Is there any difficulties?
Sir, without internet, we cannot use.
Okay, sir, there is no issue. You can we'll share the recording link as well. You can try after this.
No, sir. My question is that without internet, we cannot use Jupyter notebook.
No. There is no need for internet, sir. We can access the Jupyter notebook offline itself. So that's why we are installed this software as offline.
Okay, sir. Okay. Thank you.
There is no need for internet for doing this program. We need internet only for downloading these applications. Hereafter, no need for the internet.
Okay, sir.
Okay, sir. Thank you. Dear participants, shall we go for the next agenda?
Yes, sir.
Yeah, sure. Thank you. Okay, so after clicking this launch button, you can navigate it to just have shared some other screen. Yeah. Is this visible?
Yes, sir.
Okay, ma'am. Thank you. Okay, so this is our programming file. Already have coded, for example, Python programming. I have done some codings for the today session. So by reducing our time factor. Okay, that's why I have coded for previously. We can explore this coding with this session. Okay, so before starting this, we need to know about what is Python. Already we have seen the Python programming. Python programming is high-level programming language. We can interrupt this Python programming. So that's why we are choosing the Python programming for coding purpose. Okay, so here we can use the packages in the Python. We have several packages to explore the particular concepts. Okay, so in today's workshop, we are using the SymPy. Okay, so this is a package name SymPy. So SymPy is one of the package in a Python programming. In this package contain the many mathematical operations. Okay, so like differentiation, integration, like a simplification of any equations, or we can use the SymPy is algebraic. We can solve the algebraic concepts. Okay. Yeah, sure, sir. We will share the recording link. We can explore this code. Suppose if I share this Jupyter notebook itself, our participants only try this particular commands. Suppose if you see in this video, and if you are trying this, you can explore in own. So some other ways in advisors told me, if you share this Python notebook, so our participants will not do new things. So that's why, sir, yeah, share the video link. You can code this particular content.
Sir, can you repeat the process?
Ma'am?
Can you repeat the process?
Yeah, sure, ma'am. Sure. Okay, so already I have shared the Anaconda navigator page. Just click the Anaconda navigator in home page. For example, Jupyter notebook. Okay, so just click the Lands Jupyter notebook. We can navigate it to this current window. Okay, so this is a Jupyter notebook window. Okay, so this is my program title, Python programming for mathematics. Okay, so first we need to know about the Jupyter notebook working process. Okay, so this Jupyter notebook is very easiest and friendly manner. For already we are familiar with MS Word. It's look like MS Word. Okay, so here we have the same options: file, edit, view, insert, cell, kernel, wizards buttons are available. So in this file option, we have a certain comments, like if you want to create a new notebook, so just click the new notebook. Or if you want to use some other notebooks already existed, so just we can open that. We can copy and we can save this particular notebook, like the basic uh, operations available in the file. Okay, so the next we have a edit. So in this edit button, we have a we can copy cells, cut cells, and we have a undo, redo options, and we can merge the cell, and we can replace, find and replace options are available. We are using this concepts in MS Word itself, so that's why we can omit this. The next view button. So here we have a toggle header and toggle toolbar. Okay, here we have a we can max this toggle option. Then we have this one is very important. Insert cell. This is called the cell. For example, I have a in closed bracket. We have a this particular cell. So this is called as a cell of this particular programming. Okay, so Jupyter notebook contain the many cells. So if you run this particular command, so just select this cell, put the run button. After that, the cell will be executed for running. Okay, so here we have a the cell. So this is newest for in the Jupyter notebook. So this is a run cell. Here we have a shortcut as well. If you are run the particular enter, that cell will be run. Okay, so the run cells and select below. Okay, so this is a shift minus enter, and insert below. So these are the options available in the cell, and here we have a kernel. So this is the kernel. The kernel. We can interrupt, we can restart, and we can clear the output, and we can run all the cells. Here we have many options, and we have widgets also. We can use some other widgets for this programming. Okay, so here I have used some shortcuts for. So these are all the shortcuts regularly used, so that I can uh, introduced here. Okay, so this is a save button. You can, if you click this, you can save. Okay, suppose if you want to add a new cells, so just click this, just plus the enter plus button, the new cell will be added. Okay, so this is our new cell. Like that, we have a cut option, we have a copy, and we have a paste. We have, this is a navigation. Suppose you want to navigate to the previous cell, so just click this, so you can navigate it to previous cell. Okay, so here we have a run button. If you click this run button, the code will be executed, and here we have a pause. This is a restart, and like this. Suppose if you want to put this some other, just change. We have this uh, introduce installation of package. Okay, so first need to install the package. Okay, so this is a package. Is it audible, man? Okay. So this is a package name. This is a SymPy. So this is already available in the latest version. Suppose if the version is not available, you can install the packages, the single line command. For example, like so just wait. I will see that command. Yeah. So this is a just I have introduced some other. Okay, so this is official code for install the SymPy. So the all the latest version, this is available. Suppose if the package is not available, so this is a coding for install this particular package for your program. Okay, so pip install SymPy. So this is our package name. Okay, so after installing this package, so just import that particular package for our programming purpose. Okay, so now we are import the SymPy package. Okay, so the SymPy is a longest word, so that's why I have this renamed into SP. Okay, so import SymPy as SP. Okay, so SP is nothing but I have put the new name for a SymPy. So here we can access through the SymPy in using SP. Okay, so here I have an example. Suppose here SP
Sir,
dot symbols. Yeah, yes.
sir, how we will be able to check that which packages are installed in our Anaconda and which are not?
Sir, the recent version, all the packages are installed. Suppose if you are trying the new software, so there will be error. So this package is not available in your IDE. So in this particular error is arising, you can use this particular command. So just pip install. So this is a common
Okay,
for
okay,
every packages. Just pip install, then your package name. This is a syntax. Suppose if you want to package the if you want to add the network X, so this is another one package for using the graph theoretical approach. Suppose if the package is not available, so just pip install network X. So the package will install for your IDE. So this is a general syntax. Okay, sir.
okay,
Is
sir.
there any doubts? Okay. Okay. So we can access SymPy using the SP. Okay, so SP dot symbols. Okay, so this is a defined expression for. Okay, so now is there any doubts for installation of the package and import the packages? If there is no doubts, we can move on to the binomial theorem.
No, sir. No, sir.
Okay, ma'am. Okay. Okay, so the next we will see about some algebraic concepts for introducing the Python programming. Okay, so for example, in algebra, we have a huge concepts like we have a binomial theorem, we have a Taylor series sequence, and we have a polynomial equations, we have several theorems, and we have finding the roots, we have finding the nth term, we have identifying the some terms of the equations. For example, what is the coefficient of nth term? Okay, so like that, we have a many concepts. Here we can attain the minimal level of codings. Okay, suppose if you have any doubts regarding your particular area, so just ask me. I will try to that code that concepts as well. Okay, so just here we have a binomial theorem for any rational index. Okay, so this is a coding for the binomial index. This is just I have imported. So you can introduce the import package in the header itself. Here we are all the beginners, so that in the each command I have introduced this import. Okay, so if you are well versed after the Python programming, you can introduce the import section in top cell itself. There is no need for in each and every cell's import. You can define and you can access. We are in the beginners, so that I have introduced all the cells the same syntax. Okay, so you can't repeat this syntax and all the cells. Okay, we introduce the before and we can access. So that is the concept, like that. Okay. Okay, so first one we have input the simpy as a SP, and here we have defined symbols and variables. Okay, so here I have introduced the variables of binomial theorem x comma r. Okay, so x comma r is a variables of binomial theorem. Here we have sp dot symbols. Okay, so this is like a symbols, so that's why I have introduced sp dot symbols x comma x r. Okay, so I have defined the expression. So define the expression of 1 plus x power r. Okay, so that's why. So in Python programming, so the power root is powers. We can add the double star. If it is in the multiplication, we use the single star. Okay, so here 1 plus x power r, so that I have put the double star. Okay, if you put the double star, that denotes the power of that particular area. Okay, so here 1 plus x whole power r I have introduced. Expression is equal to 1 plus x whole power r. Okay, so already I have introduced the simpy. Simpy is a mathematical package. Here this simpy package includes the binomial series as well. So that's why we can call the binomial series for our programming. So just this is a binomial series. Here we can approach the series. Okay, so sp dot series. Here our expression is 1 plus x double star r. So here we can access fifth term. Okay, so this is a variable and this is a initial term. So this is a final term. Okay, so here expand up to fifth term, so that so after that we can print the binomial series. Okay, so just select this and click the run button. Yeah, so this is a oh sorry, so this is a fifth term of the binomial sequence. For example, 1 plus r power x n into x squared r minus 1 by 2 r into x cube r minus 2 into r minus 1 divided by 6, like that. So this is a fifth term. For example, I need the second term. So just run this. So this is a second term of the binomial sequence, 1 plus r power x in plus 0 into x squared. Okay, so like that we can explore this binomial sequence, and we have a, if you want, so this is another example. Here we have explored the 10th term. Yeah, yes, ma'am.
Sir, your screen is not visible, sir.
Screen is not visible. Just wait, ma'am. We'll check. Just wait, ma'am. I will check. Is it visible?
Yes, sir.
Sir, it's visible, sir.
Thank you, ma'am. Thank you, ma'am. Thank you for your input. Okay, so so this is a basic programming for access the binomial series. So the next one is exponential series. If you are using the exponential series in your topic, so this is a exponential series used to represent the exponential function. So like a power series. Okay, so here we can use this is a coding for series equal to sp dot series. Here we have sp dot exponential of x here up to the 4. Our initial term is 0, and our longest term is 4. The final term is 4. So just run this button. Yeah. So this is a exponential series up to the 4th term. 1 plus x power 2 by 2 plus x square x power 2 by 2 x power 3 by 6, like this is a 0. Okay, so here we can access the exponential series, and we have a polynomial equation. So if you want to construct the polynomial equations, so the same similar option. Okay, so here we have a the same. This is a same for all the programs. First two comments are the same for all the codings. We can, if you want to define in the previous manner itself, you can't, you no need to repeat this. Okay, so the polynomial equations. So this is our coding. The polynomial underscore equation. We can use sp dot. Here we can use the equation. Equation is our template. So this equation here I can introduce the x cube minus 4x squared plus 3x minus 2. So this is our equation. So we need to print this polynomial equation. So just run this. So this is our equation, x cube minus 4x squared plus 3x minus 2, which is equal to 0. Okay, so so this is a purpose for uh, defining the polynomial equations in the Python programming. Okay, suppose if you want to identify a plus b whole square formula. Okay, so a plus b whole square formula we are all know about, a squared plus 2ab plus b squared. Here we need to construct a plus b whole power 10. Okay, so this is a coding. I have already tried this. So a plus b whole power 10. Okay, so this is already we have seen. This is a basic template, basic syntax for this program. Expression equal to a plus b. So double star means that the power 10. Okay, so here we have expand expression sp dot expand. Okay, so this is a operator for expand this equation. Okay, so just run this. Okay, so this is a expansion of a plus b whole power 10. A power 10 plus 10 into a power 9 into b plus 45 a power 8 into b squared plus 120 a power 7 into b cube plus 210 a power 6 into b power 4 plus 252 a power 5 and into b power 5 a power 10 sorry 210 into a power 4 into b power 6 like that. So this is a expansion of a plus b whole power 10. Okay, so you can access the many thing. Suppose I want this for 100, a plus b whole power 100. So this will be executed. Okay, so for example, this take the huge space. Yeah, yes. So this is an expansion of a plus b whole power 100. Okay, so
Sir, voice is muted. Voice muted.
okay, ma'am, I will check, ma'am. Yeah. So this is a plus b whole power 100. Okay. So like that, we can explore any concepts. For example, I want to expand a minus b whole power 5. Okay. So just run this. So this is a expansion of a power 5, a minus b whole power 5. So a power 5 minus 5, this is a equation. Suppose if you want a plus b plus c, here we need to introduce the c as well. Here we are using the
Expanded
c.
underscore, sir.
Yeah, yes, ma'am. Yes, ma'am. Here the left hand side is our definition purpose, ma'am. There is a no there is a no need for put like this. We can access we can put any name, but the right hand we have a sp dot expand. So this is a coding for expand this particular equation. Here we can access, we can put any name. For example, you can put expand itself. You can put any name. The right hand side we have, this is a operator for expand this particular programming. sp dot expand. So this is a code. Okay, so here we can introduce C as well. So just run this. Yeah. So this is a plus b plus c whole power 5 formula. Okay, so a power 5 plus 5 into a power 4b. So this is a formula for a plus b plus c whole power 5. Okay, so like that we can change this template for our purpose. For example, if you want a plus b plus c plus d whole power 5, you can access this particular coding to construct your polynomial equations. Is there any doubts regarding this? Shall
No,
we
sir.
move? Okay. Okay, so we need to, for example, I want to check what is the coefficient of A6. Okay, so I need to know. Here we have a, what is the A6? Yeah, I need to check what is the coefficient of A6. So just we need, this is a command, expanded expression dot coefficient. Okay, so this is a command for identifying the coefficient. So this is a basic syntax. Expanded, already we have expanded the equation, just we have expanded underscore expression. So dot coefficient. This is a command to identifying the coefficient of any variable. Here we can identify the A6. Okay, so just run this. The a power 6 coefficient is 0. Where is the a power 6? Think. Okay, so here in this equation, we'll check coefficient of coefficient of C power 5. Okay, so you can check. Okay, so we can plus B whole power 5. Just run this. Okay, so now we are introducing the E power
Can we get this
coefficient.
material, sir? Excuse me, sir.
Sure, ma'am. We'll share the recording link, ma'am.
Okay, thank you, sir.
Okay, ma'am. Okay, so this is a coefficient. We need to identify the coefficient of A6. Okay, so just run this. So this is a coefficient of A6, 2 power 10 B power 4, 2 power 10, no, sorry, 210 into B power 4, 210 into B power 4. So this is a coefficient of A6. Okay, so like that we can approach this. Okay, so this is a coefficient. Okay, so here B power 6 is available. So this is a coefficient of 2 power 10 into B power 4. Okay, so like that we can check the any coefficient in this particular term. For example, here we have tried A plus B whole power 100 like that. Okay, so just we can try A plus B whole power 100, A plus B whole plus 100. So just run this. So we need to identify what is the coefficient of A45. Okay, so just you can check what is the coefficient of A45. So just we can change the comment. So this is A45. A45. Okay, so just run this. Yeah. So this is a coefficient of A power 45. Okay. So this is a huge amount. So it's a large amount. So this is a coefficient of 45th term of A power 45th term. Okay. So this is amount, and this is a B power 55. This is a coefficient of this. Okay. So by using this Python programming, we can explore the concepts until any numbers. So that's why we introduce this. Okay. So the next we move on. Is there any queries for identifying the coefficients of in any values?
Sir,
No, sir.
Yeah. Yes.
sir, excuse me, sir.
Yeah. Yes, ma'am.
Sir, when I'm running, as you get before, I also got 0, sir. But
Ma'am, just I have in previous command, I have put A plus B plus C whole power 5. So there is no coefficient available for A power 6. That's why I have changed A plus B whole power 10. So if you expand A plus B whole power 10, so there will be A power 6th term. In the previous example, we are only have A plus B whole power 5. There is no A power 6 coefficient. That's why that shows the 0.
Okay.
Okay, so if you try A plus B around above 6, for example, A plus B whole power 7, expand that, then we can easily identify A power 6th coefficient.
Okay, sir.
Okay, that is the purpose. Okay. So then next we move on to AP, so arithmetic progression. Okay, so we can explore this arithmetic progression in Python programming. Okay, so we need to explore the 10th term of the arithmetic sequence. Okay, so just here, this is my first term. First term is equal to 3, and their common difference is 2. Okay, so their common difference is 2, and I generate, yes, ma'am. Okay, so I need to generate this AP for these condition. So the first term is 3 and the common difference is 2. Okay, so this is a formula for generating the arithmetic sequence. Okay, so this is a general structure. Arithmetic sequence is equal to first term plus I into common difference. Here we need to use the for loop for I in the range of 10. Okay, so the maximum term, I need to identify up to 10th term. That's why the range is at 10. Okay, so here I need to display this particular output. So just run this. Okay, so this is a arithmetic sequence up to the 10th term. Okay. Okay, so the first term is 3, the second term is 5. So the second term is 5 and the third term is 7, 9, seventh term is 9, and like that we can approach the 10 terms in the AP. Okay, suppose if you want to add the 100 terms, so just we can change the 100, just run this. So this is a AP with 100 term by following the condition. Okay, so the first term is 3 and the common difference is 2. So here we have 100 terms available in this particular approach. Okay, so we can change the you can change the values as well. Okay, so the common difference is 5. Okay, so I need to explore the 1000. Okay, so just run this. So this is a so this is a output for first term is 3 and the common difference is a 5. So here we have 1,000 terms available in this particular output. Okay, so 3, 8, 13, 18, 23, 28, like this we can get outputs. Okay, so is there any doubts regarding this AP with generating the terms? Dear professors, so this is a very basic level. We have students as well. That's why we are covering the basic concepts for the today's session. Okay, so if you are knowing this, please keep the passion. So tomorrow we will see in the advanced concepts. Is there any queries regarding this AP?
Yeah, sir.
We can send. Yeah, yes, yes, ma'am. Here we can generate any number of terms, any common difference in any initial values. Is this audible? Okay, ma'am. Thank you. Okay, so the next one is identifying the nth term. So like we need to identify the position of the particular term. Okay, so for example, I need to identify what is the position of the terms. For example, I need to identify what is the ninth term of this condition. The first term is 3, the common difference is 2. I need to identify what is the ninth term. Okay, so this is a condition for the identifying the ninth term. So ninth term, which is equal to first term plus n minus 1 into d. This is our formula. This is available in the schooling itself. N a plus n minus 1 into d. So here we can use that the formula for identifying this. Okay, so just run this. Yeah, so this is a 19. Okay, suppose I want to identify the common difference is 5. I need to identify what is the 99th term. So just run this. So 493. Okay, so in this output we have a 493. So this is a 99th term of this output. Okay, so this is a 99th term of the output. Okay, so is there any queries regarding this? Identifying the particular term in the AP. Okay, I hope there is no queries regarding this. Okay, So the next one is we need to identify what is the last term. Okay, so the same syntax is for identifying this. Okay, so the number of terms is equal to last term minus first term. Okay, so this is identifying the number of terms in this particular AP. Okay, so here we have a around 1000 terms is available. So the initial value is 3. The initial value is 3 and the final value is 4998. Okay, so here we can change. First term is 3, common difference is 5, and nth term is, I need to identify what is the 9. So the last term is here we have a 4998. I think 4998. 4998. 4998. Okay, so just can run this. Okay, so this is a terms of arithmetic sequence. The number of terms in the arithmetic sequence is 498 terms are available in this particular condition. Okay, so the first term is 3 and the common difference is 2. The last term is 4998, means that there are 2498 terms available. Okay, so in this previous example, we are putting the common difference is 5. So here we need to interchange the common differences of 5. So this will source around 1000 terms. Yes. So this take the 1000 terms. Okay. So this is our previous example. Okay. So here we have a 1000 terms available for this particular conditions. Okay. The first term is 3. The common difference is 5. Here we can introduce the last term. So the last term is the 4998. Here we can identify the number of terms in this particular condition. Okay, so here we have the number of terms for these conditions is 1000. Is there any queries regarding this AP? If there is no queries, we'll move on to GP.
Sir,
Yeah, yes, ma'am.
sir, why we are using double slash for dividing it? We can for finding the number
Ma'am,
of
already in Python programming, we have some basic syntax. Ma'am, already I have introduced in the fundamentals itself. If you are multiplying this any two variables, we need to put single star. Okay, if you are
Okay.
if you need to put the powers, we need to add the double star. The same as well, if you are using the dividing condition, we need to use double slash. Okay, so if using the single slash, so that will provide the numeric that will provide the variables outputs. Okay, so this is a basics in Python programming. If you are dividing, we need to put double slash. If you are putting the powers, we need to use the double star. If you are in a multiplication, you need to use the single star.
Okay. Okay.
Yeah, yes, absolutely, sir. There is an integer division. Okay, shall we continue? So the next one is geometric sequence. So we are called as a GP. So the same scenario for the previous AP, like that AP. Okay, so the same syntax we are using this. For example, define the first term and common ratio. Here we have a first term is a 3 and the common ratio is 2. Okay, so we need to construct the fifth term of this geometric sequence. Here the geometric sequence is equal to first term into common ratio into I. So the range of I is to the 10th term. So here we need to replace this 5. Okay, so we need to identify fifth term of the given condition. Okay, so just run this. So this is the first 5 terms. For example, 3, 6, 12, 24, 48. This is a geometric sequence of the given condition. Okay, So the same like that, the previous command, we can explore many equations. For example, we can change the first norm, we can change the common ratio, we can change the number of terms as well. We can identify any number of terms with any initial values in any common ratios. Okay, so we are already explored this in previous concepts itself. So due to the time constraint, we can. Is there any queries? So if there is no query, we can move on to the next agenda. So the same, we can use the several way other examples. Okay, I hope there is no queries regarding this. Okay, so the next one is identifying the nth term in GP. Okay, so this is a common term. Okay, so the first term is 3, the common ratio is 2, and here we have to identify 49th value of this particular input. Okay, so just run this. Yeah, so this is a 49th term of the given condition. The first term is 3 and the common ratio is 2 means, so the 49th terms will be like this. This is a huge value. It will arrive the 49th term. Okay, so this we can reduce this as a 10th term. Yeah, so the 10th term is 1536 for the given condition. The first term 3 and the common ratio 2 means the 10th term is 1536. Is it clear? Is there any queries? Okay, so I hope there is no queries. Okay, so the same concept, we can access the number of terms as well. Okay, so we can we need to identify what is the 48th term of this particular condition. So just run this. So this is similar to the AP. That's why I have speed up this particular concept. Okay, if you are have any queries, kindly ask that query. We can rectify. Okay, so the same syntax for AP. So the first term, common ratio, the last term. So here we have a formula, number of terms is equal to math.log last term divided by the first term, the common ratio plus 1. So that's why we have run this. Okay, so the number of terms in the geometric sequence is 5. Okay, so if you are explore the 48 is the fifth term. Already we have, yeah, yes, this is a condition. The fifth term is 48. Okay, so we can access this. The fifth term is 48. Okay, so I hope there is no query regarding this AP and GP. So next we move on to Fibonacci series, Fibonacci sequence. Okay, so I hope already familiar with Fibonacci sequence. So we'll see only coding. Here we need to define the number of terms in the Fibonacci sequence. I need to expand the 10th number of term is 10. Okay, so the number of term is 10. Suppose if you want to change the values, we can change. Okay, so that's why I have provided this. Okay, so the initialize the first two terms of the sequence is 0, 1. So this is my first and second term. Fibonacci sequence, this is my first and second term. So this is a coding for executing the Fibonacci sequence. Okay, so like while length Fibonacci sequence that should be less than number of terms. So the number of term is 10. We need to put the number of terms less than 10. So that's why I have introduced here. So the next term which is equal to Fibonacci sequence minus 1 plus Fibonacci sequence minus 2. Okay, so this is a condition. So this is a general condition for generating the Fibonacci sequence. So I have put here. So then the Fibonacci sequence dot append the next term. Okay, so the loop will be extended for the next term. If the condition is satisfied, this loop will be extended for the next. Okay, So this is a basic command. So this is a output for the Fibonacci sequence of up to the 10th term. So the first term is 0, so the second term is 1, the third term is 1, the second term is 2, 3, 5, 8, 13, 21, 34. Okay, you can explore this any number. For example, if you can access the 50, so the output will be displayed. So this is a Fibonacci sequence with the number of terms 50. Okay, so is there any queries regarding this Fibonacci sequence?
Sir,
Yeah. Yes, ma'am.
hello. Sir, what
Yes.
does this Fibonacci sequence -1 and -2 represents?
We need to change. We need to change the Fibonacci sequence initializing the first two terms value. So if you change, that will execute the same command for your appropriate result.
Does this -1 and -2 is resembling the positions like
Yeah. Yes,
first,
ma'am. Yes,
second,
ma'am.
third?
Yeah. Yes. Yes. Yes.
Okay, okay.
Okay. So shall we move the next?
Sir, excuse me, that is the
Yeah,
general command, sir. Fibonacci sequence -1 plus Fibonacci sequence
yes.
-2.
Yeah, yes, ma'am. This is a general sequence. We need to assemble the positions. So like we have a 0, 1, 2, 0, 1, 1, 2, 3, 5, like that. We need to assemble the general position for assigning the position value for this particular command. So that's why we are using here. The next term is equal to Fibonacci sequence -1 plus Fibonacci sequence
Even if it
-2.
is your 10th equal to 20 means also the same command, sir.
Yeah, the same commands, ma'am. We can use in the Fibonacci sequence. We can use the same command if you are changing the initial and final values here,
By
and we
nth
can
term is equal
access
to
the
20
number of
means what
terms.
we have to change it, sir?
We need to change here. Instead of 50, we need to change the 20. So this is a 20 terms. 0, 1, 1, 2, 3, 5, 8, 13, like that. So this is a 20 terms available here.
Syntax is same. Fibonacci sequence -1 plus Fibonacci sequence -2 that is the general command, no?
Yeah. That is a general condition, ma'am.
Okay. Thank you, sir.
Okay. Ma'am. So the next one is arithmetic series. Okay. So in the arithmetic series, already we have well versed in this arithmetics. Yeah. Yes. Is there any queries? Okay. Thank you. Okay. So so this is an arithmetic sum. So this is an arithmetic sum for calculating the arithmetic sum. Okay, so here the initial value is 3 and this common difference is 2, and we need to sum up the first 50 values. Okay, so this is a basic inputs: a equal to 2, d equal to 2, and n equal to 50. Okay, so this is a condition for finding arithmetic sum. Okay, so arithmetic sum is equal to n divided by 2 into 2a plus n minus 1 into d. Okay, this is a formula to identifying the sum of the series. Okay, so just run this. Okay, so the sum of the first 50 terms of the arithmetic series is 2600. Okay, so here we can say this is a general command. We can access any numbers. For example, you can change the initial values, you can change the common difference, you can change the nth term as well. Okay, so you can, if you change this, you will get the outputs. Is there any queries regarding the sum of the sequence? So this is specifically for our graduate students.
Can you share this file, sir?
Sir, I didn't get. Sir, your voice is not clear, sir. Hello.
Can you share this file, sir?
Sir, your voice is not yet clear. I think you are asking the slides. We will share the recording link as well. You can access the recording link for the hands-on purpose. Okay, shall we move the next concept? Okay, this one is geometric series. So geometric series, we have to the same command used for this geometric sequence. Okay, so here we need to ask a is equal to 3, or is equal to 2, and n is equal to 5 for calculating the summation of GP. Okay, so here the geometric sum is equal to a into 1 minus r power n by 1 minus r. Okay, so like this we can approach this. This is a general formula to identifying the geometric sum. Okay, so here we need to change the initial and final values. Okay, so that is the concept here. Okay, so just run this, you will get the output. Okay, so yes sir, if you're using the single slash, so that will provide the decimal values. Okay, so that's why in the previous term we are using the double slash. Okay, so that is called the numeric sum, and we have a division sum, so like that. Okay, so that's why we are using the slash. Okay, so here maybe, so the sum value should be the decimals as well, so that we are putting the single slash. Okay, so the next one is a harmonic series. So in this harmonic series, we have a AP and GP as well. So here the number of term is 10. So the partial, we need to ask the partial sum for the harmonic series. Here we need to add the partial sum is 0.0. So the harmonic sum is nothing but for the I is range from 1 comma n plus 1. So the partial sum is 1.0. Okay, so the initial value is 1. We have a partial sum 0.0. So the 0.0 will be added to this one. So that will be added to 1.0 divided by I. Okay, so this is a general coding for harmonic series. Okay, so if you run this, the sum of the terms of the harmonic series is like this. Okay, so this is a 2.289. So like that, this is a harmonic series of the given input. Okay, you can change the, as well as already we have prepared, can change the values as well. Okay, you can change the number of terms, you can change the partial sum. So you can explore a particular command. Okay, so next we will move on to the binomial series. So the binomial series, already we have seen the binomial series for the rational index. Here we'll see the generic binomial series. Okay, so here we need to define the symbols a comma b comma n. So sp dot symbols, here we are using the three symbols a, b, n. So that's why we are introduced here. So then the expression of a plus b whole power 5. So this is already we have seen this one a plus b whole power 5. So just run this. So this is a this is a value of this particular binomial expansion. Okay, so the next one is this is already we have seen, that's why we are omitting this. The next one is Taylor series. So Taylor series, we have one of the basic level of research concepts. We are using the Taylor concepts in yes sir.
Sir, what's the significance of writing force equals to true in the above input of binomial expansion?
Sir, voice is not yet clear.
Sir, I am asking what's the significance of using force equals to true?
So expression the force is equal to true means that so this value will be applicable. We need to expand this expression the power value, sir. So we need to ask the Pascal triangle in this manner. So the coefficient value will be like that. If you are using the force value is a false, so just I can try. So the result will be like this. Yeah. So the result will be like this: a power 5, 5 into a power 4 into b. So like that we have input. Okay. So this force is nothing but we can fix this particular value a plus b whole power 5. Okay. This is a data science approach, sir. This force will not affect our output.
Oh, okay, sir.
Okay. So if you are doing the particular research in the decimal point, for example, a plus b whole power 0.5. Okay. So then there will be there we need a force. If you are using the numerical values, the force is force no need to affect your output.
Oh, okay, sir.
Okay. Okay. So that is the difference. Okay, so the next one is Taylor series. The Taylor series, we have two variables. So like x and a, we need to introduce the symbols x and a. So like this, already we have seen. So here we need to define the function. So the function is nothing but f of x is equal to sp dot sin x. Okay, so here we need to use the sin x. So already we have seen sp is nothing but simpy. Already we have used simpy as sp. So that sp is here. So in this package, we need to access this sin x. So that's why we are adding sp dot sin x. Okay, so the sin x, it is available in this simpy package. So that's why we are called this sin x in the simpy. Okay, so sp dot sin x, that is the meaning of we need to extract the sin x from the simpy. So that's why we need to put sp dot sin x. Okay, so here the calculation of the Taylor series expansion. So Taylor series is equal to sp dot. So this is series. So here we have sp dot series. So this is our function f of x is equal to sp dot sin x. So we can here this is f of x. Our variables is x comma a. So here we have introduced, and the number of terms here we have a 3. Okay, so just run this. Yeah, so this is a Taylor expansion of f of x centered at a. Yes, sine of a minus x minus a into cos a minus x minus a whole square into sine a by 2 plus like this. This is a expansion of the Taylor series. Okay, so the next one is the exponential series. So the exponential series, I hope already we have seen the previous concept itself. So this is our function f of x is equal to sp dot exponential exp of x. So this is a function we are calling from this simpy. Okay, so this is a equation to identifying the power exponential series. Sp dot series is equal to, this is our function f of x. Here we have used two variables x comma a. So this is our terms. The number of terms is 10. So just run this. Yeah, so this is an exponential series of this values. Okay, so we can change, this is a 3. So this is a large value, so that I can change, this is 3. So this is a exponential of a. So the same approach, we can access the logarithmic series as well. Okay, so from the logarithmic series, we can the same concepts, we can define the symbols. So in the logarithmic series, we are using the only one variable, that is x. So here we have introduced x. Then the f of x, this is our function. So function is equal to sp dot ln x. So sp dot ln x. Here we can calculate the logarithmic series. Log series is equal to sp dot series. So the same similar command we are using for the series. Okay. So all the series follows the same syntax. Okay. So here we have a changes. Okay. F of x, x. The initial value is 1. The final value is 10. Okay. So just run this. So this is a logarithmic series of the condition, given condition. Okay. So the next one is the fundamental theorem of algebra. Okay. So just we can, we have tried what is the output of the fundamental theorem of algebra. Okay. So like that, define the coefficients of polynomial equation. So these are all the coefficient of my equation. A is equal to 1, B is equal to -3,
Sir,
and yeah, yes.
screen is not sharing.
Yeah, just wait, sir. I will check.
Sir, it is visible.
Okay, sir. Okay, ma'am. Thank you, ma'am. Sir, I think it's visible, sir. Kindly check it. Okay, so this is our variable.
Sir, one second.
Yeah, yeah, yes, ma'am.
Sir, is it necessary to give only SP for SIMP and NP for NumP?
Yeah, yes, ma'am. We can,
Yeah.
if you not define that, we need to use in anywhere numpy, 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 numpy like that. If you are use the simple abbreviation, we can access that NP as well. Okay, so that is easiest way to coding.
So
So
I can
that's
give
why
any
we can
name, sir, like one.
any name, we can put any name. So it's not include the numerical value. It's not include any comments from the Python.
Okay.
So we need to ask, for example, you can put your name as well, your short name. For example, MGK. Okay, so for example, we can put that names. So that will helpful to reduce our time.
Okay.
That's why we have introduced now.
Okay. Thank you.
Okay, so here we are using the numpy. So numpy is another one package for using this calculation. Okay, so numpy is np. So here these are all the coefficient of my equation. A is equal to 1, B is equal to -3, and C is equal to 2. Okay, so I need to identify the roots of the polynomial equation. So just we can access. So this is a command for print the roots of the polynomial equation. For root is root and roots, print root. So just run this. Yeah. So the root of the polynomial equation is 2.0 and 1.0. Okay. So here I have put the quadratic equation. So in this quadratic equation, these are all the roots. So 2.0 and as well as 1.0. Okay. So our students are very struggling to identifying the roots of the polynomial. Okay. So that's why this coding is introduced here. Okay, so in our UG and PG students as well, so they are very struggling to identifying the roots of the polynomial equations. Okay, so we can put any number. For example, the coefficient of A is 3, B is 5. We can construct. Okay, so these are all the roots of these variables. For example, the coefficient of A is equal to 1, coefficient of B is equal to 5, and coefficient of C is equal to 2. So this is the roots -4.5 and as well as -0.43. Okay, so in this manner we can identifying the roots of the polynomial. Okay, is there any queries regarding this?
Sir, you have inserted for loop, sir.
Yeah, yes, ma'am. Yes, ma'am.
Why do we need, sir, for loop?
Ma'am, we need to identify the each and every term, so that's why we are using the for.
Okay. So since three constants are given, it assumes there are two roots has to be found. Correct, sir? Since
Yeah,
there are
yes.
three constants. Okay.
Yes.
If it is quadratic equation with only as x square plus 1 is equal to 0, we have to input the coefficient in the middle one as 0.
Just we can try, ma'am.
Yeah, fine. Thank you, sir. Got it.
Okay. Just wait.
Sir, will it give the answer in fraction?
Yeah, yes.
What is the command, sir?
Just wait, ma'am.
Yes.
Is visible? Okay. Thank you. Okay. So in the chat box, they asked what is the programming for cube roots. Okay. So if you are finding the cube roots, so this is a command to identifying the cube roots of this particular equation. So here we need to add x is equal to sp dot symbols. So x cube minus 8. So this is our equation. We need to identify what is the cube root of this. So just run this. So this is the cube root of this particular equation. Okay. So the cube roots are, the first root is 2, the second root is minus 1 square root of 3i minus 1 plus square root of 3i. Okay, so this is a way to identifying the cube root as cube root. If you are finding the some other terms, for example, x power 5, you can put like this. Okay, so for example, instead of x cube, I need to identify x power 5. So just run this. So this is a 5 roots of the equation. Okay, so 1, 2, 3, 4, 5. Okay, so these are all the 5 roots for this. Is it clear, sir? From the chat box, I don't know the name of this.
Hello, sir.
Yeah, yes.
Can we not solve cube root in NumPy?
Yes, sir. That is also available. The NumPy as well. We can solve the cube roots.
Okay, thank you, sir.
Okay. So the same, both are similar packages. So we are using the SymPy is for simplification process. So that's why we are using SymPy. So the NumPy is also, we have many mathematical concepts are available there. If you are using the simplification process, we are using the SymPy. Okay, so is there any queries regarding this? Shall we move the next agenda? Okay, I hope there is no doubts regarding this. Shall we move the next agenda? So as of now, we are exploring the concepts that is available in the algebra. So if you want some other algebraic concepts, just put it in the chat box. If you have a time, we will see in this end of the session. Okay, so as of now we are seeing the many basic algebraic concepts. Okay, suppose if you want to explore the new concepts, I will explore. So just we have infinite series sum. Okay, sir, we'll explore in the end of the session the infinite series of sum. So, dear participants, if you have if you want any other algebraic concepts, just kindly unmute your mic. If you want to explore some other new algebraic concepts, kindly put your questions in chat box. I will see in this end of the session. Okay, so now we move on to the calculus. So the calculus is one of the familiar mathematics domain. So just wait. Yeah, muted. Okay, so the calculus is one of the domain one of the biggest domain in mathematics. We are using the day-to-day life to identifying the calculus concepts. Okay, now we are implementing the Python programming to solve the simple Python calculus problems. Okay, so first we need to we will see about limits and continuity. Okay, so this is one of the concepts in calculus. We are seeing the limits of the function. Okay, so first we need to define the variable and the functions. Here we are using the x as a variable, so that x is equal to, here also we are using the package sp, so that sp dot symbol is equal symbols. Here this is our variable. Next we need to introduce our function f of x equal to 4x. Okay, so this is our function. So we need to calculate the limit as approaches to 2. Okay, so this is our condition. So limit result as 2. Okay, so just we need to this is a command to identifying the limit values, sp dot limit. So this is our function f of x. So this is our variable x, and the approaches limit is 2. Okay, so just run this. Okay, so if you are using the limit as a 2, that give the result as 8. Okay, if you put value of x is equal to 2, that result gives 8. Okay, so the similar previous concepts, we can change any number of values from this general condition. Okay, so for example, I want to put 4 power x. So 4 power x, I need to identify the value of 5. Okay, so just run this. Yeah, if you so this is a this is 5. Yeah, so limit of the 5 approaches, 5 is equal to 1024. Okay, if you put instead of x 5, so 4 power 5, so 4 power 5 is the value is 1024. So by using this command, we can identify the limit values. Okay, so that is one of the concept here. Is there any queries regarding this limit values? Okay, so the next we move on to continuous and not continuous function. Okay, so here we need to introduce some other new package, matplotlib. Yeah, yes, ma'am.
Sir, slide is not moving, sir.
Just wait, ma'am. I will check. Is the screen is visible?
Yes, sir.
Yes, ma'am. It is visible, ma'am. Kindly check your internet connection. So it's visible.
Ma'am,
Suppose if not
excuse me,
visible,
sir.
just yes, ma'am.
Import matplotlib dot pyp dot lot. Put it in.
Yeah, yes, ma'am. This is one of the new package here we are introduced. The matplotlib is useful for plotting the diagrams. So if you are plotting the diagrams, so this package will be useful for plot the diagrams. So that's why we are using this matplotlib dot pyplat. Okay, so this is a short name PLT. So we are using this abbreviation for the this program. So this is another package, ma'am. As of now, we are seeing three packages. One is a SymPy, another one is a NumPy. So this is a matplotlib. So there are many packages available in this Python. So now, as of now, we are using only three packages. So dear participants, just wait for 2 minutes. So we are sharing the feedback link, and after that, we'll continue the session. Just wait. Yeah, thank you. I hope the feedback link is available in the chat box. Kindly fill the feedback form before completing this session. Okay, so shall we move on to the next agenda? So we are in the calculus. So now we need to identifying the continuous or discontinuous identities. Okay, so here we have a program. So like we need to put the x values and as well as y values. Okay, so we need to check the values as -2, 0, 3. Okay, so if I put the limit is -2, that given equation is continuous or not, then we need to identify 0. So if you put in the limit as a 0, so that equation is continuous or not, and as well as we need to check 3. Okay, so we can change the any values for checking the continuity. Okay, so this is a general command to identifying the continuous or discontinuous function. Okay, so this is a definition of check continuity. So here we have defined the function. So define check continuity of x comma y. So here we need to put index. Index is equal to x values dot index. Okay, so this is a general syntax. Yeah, you can using this general syntax for identifying the continuous continuity. Okay, so and as well as we have check continuity at the specified points. So like by using this comment, I will share this recording video. You can type this. Okay, so this is a general algorithm for identifying the continuity and the discontinuity. Okay, so these are all the comments to display the graph. Okay, so just run this. Yeah, so this is f of x is not continuous at x is equal to -2. So in the position of x is equal to -2, this is not continuous, and f of x is not continuous at x is equal to 0, and as well as f of x is not continuous at x is equal to 3. Okay, so these three values not continuous for this given equation. Okay, suppose we need to change this. F of x is equal to -5, 0, and f of x is equal to 1. So just run this. Yeah, -5 is not in the list. Yeah, need to put the -1. Oh, the same similar values not at continuous. Okay, so based on the equations, we can say this will be changed. For we need to check the positive values too. Can check this. So this is also not continuous, and we can check this too. So this is also not continuous. Suppose if the given equation is continuous, we will get the continuous result. Okay, so our equation is not continuous from the following conditions. That's why it's make this output. Okay, so the next one is define variables and functions. So just wait. So please mute your mic. Thank you. Okay, so the next one is define the variable and the functions. Okay, so here we have a we are using the limit values. So for example, x is equal to sp dot simples. So this is our function sp dot exponential of sin x, e power sin x. So this is our equation, e power sin x. So this is our function. So we need to identifying the limit result. Okay, so just we can run this. So this is a limit value of if you put the limit value 0, so the result is 1. So if you put the result value is 1, so this result is it's like this, exponential of sine power 1. Okay, so like that we will get the result. Okay, so then we have used polynomial functions to identifying the intervals. Okay, so what are all the intervals between the functions? Okay, so the next one is define the polynomial function. So this is our equation: 2x cubed minus 5x squared minus 10x plus 5. Okay, so this is our equation, polynomial function. So we need to identify what is the intervals between these two values. Okay, so for example, I have put the -1 and 2 is the intervals. Okay, so just run this. Yeah, so the root of p of x within the interval -1 comma 2 is approximately 0.425031. Okay, this will be useful for the numerical methods topics. Okay, so for example, this is a basic command for the Gauss methods, Newton Raphson methods, like that. Okay, so this is a basic concepts. Okay, so in tomorrow's class, we are tomorrow's session, if you have a time, we'll see in the numerical methods for advanced level. Okay, so the next one is define the variable, calculate the limit x approaches to. So this is already we have seen in this previous concepts as well. So that's why we are omitting this, and we are moving on to the differentiation. So the differentiation is one of the main domain in calculus. Okay, so we will see what are all the differentiation concepts applicable in the Python programming. Okay, so the first one is calculation of the derivative. So if it is in a derivative functions, we have a certain formulas to to identifying the derivatives. Okay, so here we have a variables and the functions. So here the variable is ax, and we are introducing the function 3x squared minus 2x plus 1. Okay, so this will provide the answer 6x minus 2. Yeah, 6x minus 2. So this is a normal calculation from the differentiation. We need to check the Python coding. Yeah, so this is a 3x squared. If you differentiate 3x squared, that will provide 6x. Here we have 2x, so the x will be the 2. So plus 1 is a constant, that is a 0. Okay, so this is output 6x minus 2. Okay, here we can change any number of values, any number of any functions. Okay, suppose I want to identify 3x power 5 and 2x squared something plus 2, let's write 2x cube something. So this is our answer. So 15x power 4 minus 6x squared. Okay, so like that we can differentiate any functions by using this general syntax. Okay, so this is a general polynomial equation. Suppose if you are using the trigonometric function, so this is a command to identifying the differentiation of the trigonometric function. Okay, so here we have used x is equal to sp dot symbols. So this is a variable, and this is our function g of x is equal to sine x. Okay, so if you are differentiate sine x, that will provide the cos x. So we'll check. Yeah, so this is a result for the cos x. Okay, so we can change the variables. For example, sine squared x. So just run this. Sorry. Yeah. So this is a sine square x. Okay. So 2 sine x cos x. So this is a formula to explore the differentiation. Suppose we have a certain rules available for identifying the differentiation. There are product rule, constant rule, and chain rule, like that. We have many rules. Just wait.
அந்த ரூம் பெட் எப்படி தொலைக்கிறது?
Okay, so this is a general syntax for by using the product rule. Okay, so for example, here, yes, ma'am.
In the previous question of differentiating sin square x, we are using the equation like calculate the derivative g prime x equal to sb dot diff g underscore x comma x. If that x is we are using as because we are differentiating with respect to x. Is it why we are using
yes,
x
ma'am.
over there? If our function is a bivariate one and we need to differentiate it with respect to y, then we will replace it x as y, right?
Yeah, yes. So this is an x. Instead, we need to identify the based on the x. So that's why you have put. So this is a general formula. We can change as well. For example, this is a general condition sp dot diff. So this is a command to differentiation. Okay, here we can. This is our function. This is our variable. So based on your name, we can change this.
Sir, what about the second derivative, sir?
Just wait, ma'am. We'll see one by one. So in the future concepts, it is available. Is there any queries regarding this different basic level of differentiation? Okay, so I hope there is no doubts regarding this. So next we move on to so we have a certain rules for differentiation. We have a product. First one is a product rule. So this is a x squared into sin x. Okay, so this is a function x squared into sin x. So here we need to use the product rule for differentiate this particular function. Okay, so here we have the same concepts applicable here. So just run this. So this is a output for the product rule. X squared cos x plus 2x sin x. Okay, so this is a by using the product rule, we'll get the output x squared cos x plus 2x sin x. Okay, so like that we can use the product rule, and we are using I'll get the next one is the exponential. If it is an exponential function, we can use like this. Okay. So for example, e power x is equal to the same concept. E power here we need to use e power 3x. So just run this. So 3 e power 3x. Okay. So this is a answer for this exponential function. Okay. So these are all the basic mathematical concepts. So we have a certain students as well in our workshop. So many students are joining for this particular workshop. So that's why we are concentrate the basic level of concepts as of day one, and the day two we are introducing the advanced concepts. Okay. So the next one is constant function. So if you are derivate any constant, that value should be 0. So these concepts all of you know about in mathematics. So just the result is should be 0. Okay. So if you are differentiate any constant that provides 0, so this is a result. And we have a suppose if you are defining the linear functions. So this is a linear value. So 3x plus 2, obviously the result is 3. Okay. So just run through the Python programming. That's also provide the result is 3. And define the variable and quadratic function. If it is a quadratic function, so we'll get the same outputs 2x square. So this obviously this is a 4x minus 4. The result is 4x minus 4 for giving this input. We'll check through the Python programming. Yeah. So that's also provide the 4x minus 4. Okay. So this is a basic level of equation. If you want to explore this Python programming, you can put, you can instead of this equation, you can replace any values. So that will provide the output. Okay, so then the exponential function. So already we have seen this exponential function, and we have a trigonometric function. Already we have seen these trigonometric functions as well. And we are using the power rule. Yeah. So power rule. So power rule is nothing but, so this is one of the rule. It's applicable in the calculus. If you are using the 3, so 3 should be multiple in the front. Okay, so that is a power rule, and it's applicable in the thing. Here 3 is multiple into 4. So n into x power n minus 1 formula. So that's why that's formula is using for the power rule. Okay, so 12x squared minus 4x plus 7. Okay, so this is a power rule. And constant function, this is already we have seen, this provides a result as a 0. And you are using derivative using the sum rule. Yeah, so this is a sum rule. So sum rule is nothing but the normal differentiation process. And the product rule, already we have seen this product rule in the previous example. And this one is difficult for our student level. Okay, so the quotient rule or division rule. Okay, so many of our students feel difficult to identifying this in the differential equation. So Python provide the easiest solution for this quotient or division rule. Okay, so here we can we need to identify the differentiation of x squared by sine x. So this is the equation for x squared by sine x. Okay, so here we have introduced the SP is equal to differentiation of mx. Mx is a function and x is our variable. Okay, so here we have to simplify m prime x. Okay, so after identifying the differentiation, we need to simplify this. Okay, so just run this. Yeah, so this is a division rule of this x squared by sine x. Okay, so is there any queries regarding this basic basic differentiation process? Okay, so I hope there is no doubts regarding the basic differentiation process. Next, we order ODE. Okay, so ordinary differential equations. So first order ordinary differential equations. Okay. So okay, so the same similar process for the ODE, first order ODE and second order ODE as well. Okay, so the same basic. Yeah, yes. Is there any doubts? Okay, so sorry for the interruption. Okay, so the first order ODE. So in this first order ODE, we will explore some other concepts. Here we use the DSolve. So many of them aware about DSolve in MATLAB programming and as well as Mathematica. So here also we can use the DSolve. Okay, so in the Python programming as well, we are using the DSolve ODE, Y. Okay, so this is similar to MATLAB and as well as Mathematica. Already we are familiar with that particular concepts. So the same similar concepts applicable in the Python as well. Okay, so now we are using the two variables, x is equal to sp dot symbols and y is a function. Y is equal to sp dot function of y in terms of x. Okay. Okay, so this is now this is our ODE. Okay, so this is a solution of sp dot dsolve ODE comma y. Okay, so this is our function. ODE is equal to sp dot equation of y differentiation of x. So this is our equation 2xy. Okay, so just run this. So this is an output equation of y comma x. Y of x is equal to c1 e power x squared. Okay, so this is our first order linear equation result. And we are accessing the differential equation with the 3xy So the same similar concepts for explore this 3xy. Okay, so here we have a plus 3 into xy. Okay, 3xy. So equation of y with respect to differentiation of x plus 3xy. Okay, so just run this. So this is our output. Y of x is equal to c1 into exponential of e power minus 3x squared by 2. Okay, so this is our result. And if you are using the estimating using the Taylor series by using approximation process, so this is also one of the easiest process. F at 3 which is equal to 2, and f prime at f dash of 3 is equal to 5. Okay, f of 3 is equal to 2 and f dash of 3 is equal to 5. We need to identify by using the Taylor series. We need to identify the value of 3.2. Okay, so this is one of the problem. So here we have a is equal, initial value is 3 and the approximation is 3.2 minus 3. So final result minus initial result, which leads 0.2 as a value, and this is our approximation formula. Okay, so f at 3.2, which is equal to f at 3 plus h is nothing but the difference between the terms, and the frame at 3. Okay, so this provides the result 3.00001. Okay, so f at 3.2, so value is 3.00001. Okay, so like that we can calculate any value of this particular Taylor series. And we are using velocity functions as well. So position and velocity functions, that is one of the functions in the calculus. Okay, so here we are define the variable and the position of the st. So t is equal to sb dot symbol. So t is a time, and st is a t cube minus 9t squared plus 24t plus 4. So this is our function, and we need to calculate the derivative, find the velocity of the function. So vt is equal to, so we need to differentiate with respect to time. So s of t comma t. Okay, so this provides the velocity at point t, and its equation provide the rest. Okay, so just run this. The velocity function vt is equal to 3t squared minus 18t plus 24. This is a velocity function, and this is a rest timing. Okay, so in the 2,4, so this will be rest in the position. Okay, so the next one is calculate the derivative. Here we have a x value, so the x is nothing but the symbol, and u is a 7x squared plus 1. So this is a initial value, and kx is equal to cos u power 4, cos power 4. Okay, just we need to derive this particular command. So this is the answer for minus 56x sine 7x squared plus 1 and cos 7x squared plus 1 into 3. Okay, so this is a value for this particular answer. Okay, so the next one is define the variable and the functions. So this is a calculate the derivative of x cube, u is x cube, and h of x is equal to e power 6. Okay, so this is similar to the previous concepts. So just run this. It will provide 18x squared sine x cube power 5 into cos x cube. Okay, so this is the result of the particular input. Okay, so is there any queries regarding the functions? How to find integration? Sure, ma'am. We will see. Is there any queries regarding the current current topics?
Sir, can we also do
Yeah.
nth derivative?
Sir, your voice is not clear, sir.
Sir, I'm saying, can we also do nth derivative of any
Yeah,
function?
sure, sir. Sure. So finite derivative is also available.
Okay, sir. Okay, thank you.
Okay.
Hello, sir.
Yeah, yes.
Sir, actually, I have basic. I actually downloaded this Anaconda, and when I installed
Okay, sir.
and I launch Jupyter, so it directly goes on
Okay.
internet, on web. It is not, and then it is not showing me this file option there. Okay.
That
So,
is just I will show, sir. Here we have a file option. Just new document, notebook.
yes. So, sir, for this, when I now click on Jupyter,
Okay.
then directly on internet, whether this Jupyter notebook launch on internet only directly.
Yes, sir. This is a Mozilla Firefox. This is a browser. In this browser, we can
Okay,
access the Jupyter notebook.
okay. So, okay.
There is no need for internet, sir. This is a local host. This is my address. This is a local host. So this is a notebook. This is a file location, desktop, Python programming for mathematics.
Okay,
So
okay.
this is a basic. Okay, so is there any other queries regarding this? Okay, so the next week we will see the integration. So first we need to check infinite integration. So so is this visible? Next we will check infinite integration. So in the integration we have several types. So the first one is infinite integration. So we need to explore 3x squared plus 2x plus 1. We need to identify the integration of 3x squared plus 2x plus 1. So this is a general coding for identifying this. Okay, so this is this is a variable, and this is a function 3x squared plus 2x plus 1. We need to identify the integration of infinite integration of this. Okay, so just run this. Okay, so this is a result x cube plus 3x squared plus x. Okay, so this is a basic concepts of integration. Is there any queries regarding this or the integration?
Sir,
Yes.
sir, Python doesn't give constant of integration in the output.
Sir, not yet clear, sir, your voice.
Sir, I am saying Python doesn't give constant of integration in the output.
Constant of?
Sir, this is indefinite. No, sir. Limit is not there. No, that's what he is asking. Plus C will not come or not.
Yes. So next example we will check. So this is a definite integration. So in this process we will get we will put the value of x is equal to 0 and x is equal to 2. So this is a limit. Okay, so if it is an indefinite, there is a no limit process, for example. So we can compare these two. Here we have put the limits 0 to 2. This is a definite integral, this is an indefinite integral. Here we are not put the limit values. Okay, so just run this. So this provide 8/3. Okay, so this applicable, the limit value is 0 to 2. So that provide 8/3. Is it clear? Is this your doubt?
No, sir. Sir, I was asking like if in Mathematica we do indefinite integration, so
Okay.
constant of integrations are obtained in the output like C1, C2, so on. But in Python, it is not giving constant of integration.
I'm not familiar with that, sir. I will check and I will tell you in this personal chat. Okay. So
Okay,
I'm
sir.
not aware about that constant value. As of now, I will not check that. I will check and I will tell you in the personal chat. Okay. So is there any other queries? Okay, so I hope there is no queries. So அதுக்கப்புறம் the next one is integration by the substitution method. So all of you are aware about the substitution method. So this is a coding for a substitution method. For example, here x comma u sp dot symbol. Here we are using the two variables. One is a x and another one is a u. Okay, so here f is equal to e power exponent e power 2x. So this is our function e power 2x. We need to we are applying the substitution for this. Okay, so just run this. Okay, so this is a integration value of exponential e power 2 integration of e power 2x. Okay, so the next one is integration by parts. Okay, so this is a general coding for integration by parts. Here we need to access x. X is a variable, and here we can use u equal to x and dv is equal to sin x. Okay, so by applying the integration by parts formula, by using this formula, integral sp dot integral is equal to uv udv minus integral v du. Yeah, so the same formula is typed over here and we can run this. So this is an output x sin x plus 2 cos x. Okay, so this is a integration by parts. Okay, is there any queries regarding this? Yeah, sure, ma'am. Ruby Fatima, we will share the tomorrow. Just now I have checked your comments. I will check. I will send you the code and tomorrow session as well. Is there any other queries from the integration?
No, sir.
Okay. As of now, we completed algebra and as well as calculus. If there is any specific topic, if you want, kindly put in the chat box. I will try that. We will try that this hands-on. We are covering the basics of algebraic functions, algebra, and as well as calculus.
Excuse me, sir.
Is it possible
Yeah,
to
yes.
go for Laplace vectors?
Yeah, yes, ma'am. It is possible. So
Okay,
just
okay.
we can try this.
Okay, sir.
Sir, can we also do fractional derivative?
Sir, kindly put it in the chat box, sir. We can, based on the queries, we will see one by one. Just I have searched the Laplacian in my database. Yeah, I think this is a command for identifying the Laplacian. Okay, so here we can import SymPy. These are all the variable for identifying the Laplacian, x, y, z, and this is my function f of x. F is equal to x squared plus y squared plus z squared for the scalar function. Okay, so this is a integration of the Laplacian. Okay, so yeah, provides 6. The Laplacian of f is equal to 6. Is it clear, ma'am?
Yes, sir.
This is a basic one. We can explore in the advanced manner as well. This is a basic
Okay,
command.
sir. Okay, sir.
Okay. So the next one parameter for differentiation, fractional derivative. So just wait, sir. Check fractional derivative. I hope this fractional derivative is complicated coding in Python programming. Just we can check that this is a this is algorithm to finding the partial derivation. Okay, so x comma t alpha. So these are all the variables in this equation. So a is equal to 0. This is a lower limit of integration, and here this is our function sine t. We can fractional derivative 1 by sp dot gamma 1 minus alpha sp dot differentiation integral. This is a general condition for identifying the Riemann's-Leibniz fractional derivative. Okay, so this is a formula for Riemann-Leibniz fractional derivative with respect to x. Okay, so then we can change this. We can run this. Okay, so so just wait. It's take a little bit time. Yeah, it's still running. Just wait. It will provide the result. I think, yeah, it's not printing the result. Just can change this. You can run this. It's still running. So it's take too much of time. We will see the next concepts, the partial differential equations. So just wait. Instead of this, we can check this. I think there are many errors. There may have an errors. Okay, so after the ending, I think there is an error. Just wait. I will debug this error. I think there is an error for fractional derivative. So tomorrow we will cover this fractional derivative. Sorry for the delay. And next we move on to the partial differential equation. Just wait, I will check my comment box. Yeah, so this is my coding for the partial differential equation. So here we have introduced, so this is a advanced level of programming. Okay, so there is no coding available for simplest manner in my database. Okay, so here we are using the NumPy and as well as matplotlib for identifying the partial derivation of this value. Okay, so this is our this is our parameters. So L is equal to 10, T is equal to 2, and NX is equal to 100, NT is equal to 200. So this is my L dx is equal to L by NX, dt is equal to T by NT. And this is initializing the grid and solution. This is the initialization, and this is the initial condition. And here we are time stamping the loop to solve the PDE. Okay, so just I have run this. So this will provide like this. So this is an output. Okay, I have searched in my database. There is no basic level comments available in this partial derivation. Okay, so this is an advanced concepts in PD. Is this clear, Vinita? Vinita's man? Is it clear? This is a example to identifying the partial differential equation. If it possible, tomorrow I will show you for the simplest partial derivation codings. And next one is capital fractional derivative. So just wait. If it is available in the database, in my database, I will show you the capital fractional derivative. Or otherwise, tomorrow I will show you how to check the capital fractional derivative. Eigenvalues trace determinant. Just wait, ma'am. I will show you. Yeah, one of the function is available. I don't know. This is our question. So just this is a capital derivative for identifying the capital derivative functions. So just run this. I think this is also it's not providing answer. So this is a capital derivative, similar concepts. Okay, so the next one is eigenvalues and eigenvalues trace determinant. So this command is available for me. So just wait. I will show you how to find the eigenvalues and eigenvectors and trace as well. Yeah, I have identified my database for eigenvalues and eigenvectors. Yeah, So this is a result for Capito derivative. I think Vikram Singh. So is this your question?
Yes, sir. Yes, sir.
Okay, thank you.
Thank you, sir.
So the next one is eigenvalues and eigenvectors. Okay, so I have introduced the NumPy software, define the square matrix. This is my square matrix 4 comma 4 minus 2 1 comma 1. I need to find out the eigenvalues and eigenvector of this particular matrix. So just run this. So this is an eigenvalues 3 3 comma 2. This is an eigenvalues and eigenvector is 0.8944 and 0.70710, 0.4472136 and 0.70101676. Okay, so this is an eigenvalues and eigenvector of that particular matrix, and we need to identify trace and determinant as well. So just wait, I will. So this is a comment for identifying the trace and the determinant values. So just run this. The trace is 5 and the determinant value is 4. Priyanka, is this clear? Is there any queries? Okay, so I think there is no questions from the chat box. I hope this session is useful for everyone. Uh, so the Python programming is one of the useful tool to interactive session. If you are if you are in the faculty members, we are using the Python programming in as a class. So the students very engaged to identifying the concepts. Okay, so this will be introduce the interactive learning for the students perspective. Okay, so we request the faculty members and research scholars. The future research scholar is a future professors the mathematics. So we are request from the Indian Mathematics Professors Association. So kindly introduce the Python programming for your curriculum. Okay, it will lead the students power in the future research. Okay, so that is our intent to provide these types of workshop for faculty members and as well as students community. Okay, if you are providing these advanced concepts for mathematical students, so that mathematical students will lead the world in future. Okay, so each and every concepts available in this mathematics only. The people's using mathematics in the various manner. If you are teach this Python programming and advanced concepts for our kids, so that kids will lead the world. Okay, so that's why we are providing these types of workshop for mathematics community. Okay, so thank you for your patientable listening. And tomorrow session, we will see how to implement Python programming in graph theory, operation research, and we have several domains like discrete mathematics, and we have several domains. Based on the timing, I will cover the maximum topics in from the mathematics.
Hello,
Okay,
sir.
so yeah, yes.
Sir, why determinant value is not exact? Because the determinant value is 4, but this is showing 0, 0, 0, 0, then 1.
Which one, sir?
The last one, determinant value of the matrix B.
4.0001. The determinant value is 6 minus 4, 4.001. So this is a absolute value, sir, 4.001. We are using the 4 for our purpose. So this is an np dot array. So in this array, we have they are fixed algorithm to identifying the determinant values. So in the package numpy package itself, here we are not defined the determinant function. So this is already available in the numpy. We are just using the numpy. Okay, so that's why that provides 4.0001. So this is near to 4. So we can check then future concepts. For example, we can change the value like 3.7. So just we can check this. So this is a determinant value. Trace 10. It's already available in this numpy as well, sir. So this is an algorithm we are using here.
Sir, if I want to see exact value, then what package we
need to provide the command, sir. We need to provide the command. We need to define the function to identify the determinant value. So this is already defined from the numpy. So this is a
SymPy can we use SymPy here?
We can use SymPy as well. You can check SymPy. Just wait. Just wait. And this, I think there may be error. Okay. There may have an error, sir. We'll check in tomorrow's session.
Okay.
This
sir,
is available only for numpy. It's not available in these functions. Available in the numpy as well. It's not available in the SymPy.
Then there is no way to find exact value of determinant by the inbuilt function.
Yeah, it is inbuilt function. If you want the exact solution, we need to introduce the previous algorithms. We are defining that particular functions. Now we are introducing the inbuilt concept. So that's why it's provide the output. If you are if you want the exact output, we need to put the definition.
Okay, sir.
Okay. So thank you for your passionable listening. Principal component analysis using Python in tomorrow's session. Sure, ma'am. We will see in the principal component analysis. Okay. So thank you for your passionable listening. On tomorrow's session, we will see the many advanced concepts and as well as some other basic concepts as well. Okay. So thank you for your passionable listening, and we are waiting for the day 2 session. Okay. Thank you once again. If you have any queries, kindly ask me. If there is no queries, we can wind up the meeting. Yeah, yes, Sanmugh Sundaram sir. Is there any queries? Dear participants, we have already conducted the Python programming for graph theory as well. If you are interested in the workshop. That recording link is available in the YouTube channel. Just check that.